half of this assignment question has to do with something that you learned in grade 11 math. If you can recall doing something called sequence and series, then that's what we're looking at here. So I don't want to do the assignment question for you because this is something that's being handed in for marks, but I will do a similar example to get you started on the first part of this assignment. The values that you're being given here are values that form a geometric series. A geometric series has a common multiple to get from one term to the next. So in other words, you're taking one term, multiplying by a number, and getting the second term. And then you would take the second term and multiply by that same number, and so on. So I'm going to give you an example of something kind of similar. And this one has fractions as well, so it's quite similar to what you're being asked to do, just to get you started. And so when we have something like this, and we're treating it as a geometric series, which is the sum of a bunch of terms that are all related by a common multiple, we need two important values. The first value is the very first term of the series, so in our case that's going to be 1/2, and we call that a. The other really important value is r, which is the common multiple, or the number that we're multiplying each term by to get the next. Quick way to find that is to take the second term and divide it by the first term. So if I have 1/3 and I divide that by 1/2, when we're dividing fractions, we multiply by reciprocals, and so I think you'll be able to see that that is a 2/3 common ratio here. So now that we have a and we have r, the information that you're being given in the question, what you're being asked to do here is to add successive numbers of terms together and get a total, sort of a running total as you're going through this series. So you're given the answer to the first three sums here, and you're being asked for the limit as n approaches infinity of a(n), which is the sum of any number of terms. And when we say as n approaches infinity, it means the sum of like all the terms going forever and ever. So in order to find the sum of the terms of a geometric series, we need a formula. And again, this formula is something that comes from the grade 11 university math course, the functions course. It looks like this. It says the sum of n terms is a times 1 minus r to the exponent n over 1 minus r. And keep in mind that r would never be 1 because we would have an undefined denominator. We'd have a 0 in the denominator, which would give us an undefined value. So the values a and r are the ones that we need to put in this formula and find the sum of our terms. When we do that, we'll come up with a value which we can then substitute in n equal to infinity and determine what the sum of our series will be as we approach infinity. So the sum of n terms for my series would be 1/2 times 1 minus 2/3 to the n. That's going to be over 1 minus 2/3. So I have 1/2 times 1 minus 2 over 3 to the n. Sorry, that's messy. Over 1/3. And if I multiply those fractions, if I multiply 1/2 by the reciprocal of 1/3, I end up with 3/2 times 1 minus 2/3 to the exponent n. Now, I don't know if you've talked about limits too much in the class yet. I know you're just getting started. And the concept of a limit would come from your grade 12 functions for you course as well. But the limit of this particular function here is what's going to happen to it as we let n approach infinity. It might be easier for you to simplify this so that you can determine a little bit better what's going to happen when we let n approach infinity here. If I multiply the 3 halves in the brackets, I get 3 halves minus 3 halves times 2 over 3 to the n, like that. Okay. Now, any fraction that's less than 1, if we multiply it by itself infinity times, it's going to keep getting smaller and smaller. 2/3 times 2/3 is 4/9, and then multiply by 2/3 again, and so on and so on. You're making the fraction smaller and smaller and smaller. Eventually, it will approach a limit of 0. So 3 halves times 0, this whole term will become 0. The only thing that we'll have left is 3 halves. And so the limit as n approaches infinity of my series would be 3 halves. So I hope that that helps you for the first half of the question to find the limit that you're being asked to find for the series that you're given. Once you've done that, I hope it will help you with the second part of the question. And so what I'd like for you to do is have a look at that, work through part 1, think about part 2 a little bit, and if you're still having difficulty, then we'll take a look at part 2 in a separate video.